Hello, welcome students. Welcome back to Akshar IT on classes, and I'm your chemistry faculty S. Mohan. Students, here in the last class we started a new chapter, that is thermodynamics, right? Thermodynamics. Okay. Now, what is thermodynamics? This also we discussed definition. Thermo means what? Heat. Dynamics like motion. So here a branch of chemistry which deals with the relation between the conversation of the heat and the mechanical energy, also we can say, is called as a thermodynamics, right? And in this thermodynamics chapter, we discussed about the system, surroundings and universe. So, system, surroundings and universe, right? So, here students, for example, you think this is the universe, okay, means what? This is total universe. In this, we are going to discuss only about a small region, okay, a small part, okay, about this part we are going to discuss. So, this is called as a system, about which we are discussing, means on which we are studying, that is called as a system. And the remaining part which is there, this total remaining part comes under the surroundings. What it is? Surroundings, okay. And this total surroundings and system gives the universe. So, this is called the universe. This already we discussed, right? Then here students, we discussed about some systems like open system, closed system and isolated system also. So, open system is what? A system in which both energy and matter are exchanged. So, that is called a system where matter and energy are exchanged with the surroundings, okay, is called open system. So, this already we discussed, like for example, if you take one beaker, in that beaker you take some substance, this is some substance, and for example, initial mass of this substance is m1, or in terms of you to understand here, for example, we are taking like, okay, 100 grams of water, we are taking some 100 grams of water, and then initial temperature, that initial temperature is, for example, you think normal temperature 30 degrees, okay, 30 degrees Celsius. Now, what are you doing? We are heating here, okay, on heating. Then what happens? You know that the water get heated, and this heat, okay, moves to the surroundings, and when it reaches to the 100 degrees Celsius, then what happens? The water get evaporated, and water is also moving. So, the meaning is what? Here, the heat and matter both are entering into the from system to surroundings, right? So, matter and system both are exchanging the surroundings is called open system. Then what is closed system? Closed system is what? Here, for example, you are taking one, okay, vessel, and this is a completely closed airtight lid we kept here, and we are heating. On heating, what happens? Here, this water will boil, but boiled water cannot, means is converting into vapor also, but this vapor cannot enter into the atmosphere, right? So, matter is not exchanging, matter is not going away from the system, but heat may be transverse, heat, okay, going to the surroundings. So, here only energy is transferring from system to surroundings or surrounding to system, but not a matter. So, this is called closed system. Next, come to the isolated system. Isolated means what? In which no matter and no energy can be exchanged from system to surroundings or surroundings to the system. So, this students we discussed it till here in the last class, right? So, now today let us see here some important terminology. See, thermodynamics is we are in 9th standard, right? And we are discussing about the means we are this classes for IIT Foundation. And in your textbook, you don't come across the word called thermodynamics. and even so that's what here whatever the going to study in thermodynamics, so it's completely new to you. So you can come across so many new words, new terminology. So you have to understand that what are these terminologies to understand the thermodynamics properly. Clear? So students, here today we are going to discuss about some new important terminologies like macroscopic system and microscopic system. Okay, macroscopic system and microscopic system. Okay, so you know micro. What is the micro? Small. Micro means what? Small. So the properties which arises. Achha, first let's see the macro. So macro means what? The system containing large number of chemical species is called macroscopic, which consists of large number of. Okay, so large number of species is called macroscopic. Macro means what? Big. So okay, more quantity. And micro, that's a very small. Okay, if we discuss about the small quantities of the chemical species, then that is called the microscopic system. Then here we come across extensive properties and intensive properties. See, this is very, very important. Extensive and intensive. Extensive and intensive. So, see students, here we come across some properties called as intensive property and extensive property. Extensive property means what? The property which depends, okay, on the quantity of matter present in the system. Quantity of matter present in the system. Okay, means what? For example, okay, I have some object of this size. Okay, some object of this size. Right. Now here the size of the object. Okay, this is the size of the object. Right. And let's see the mass of the object. Okay, volume of the object. So this, if you see here, if I break this substance into two pieces, okay, if I break this substance into two pieces like this, I am breaking into two pieces, right? So here when I break these two pieces and I'll remove this half piece, okay, I'll remove this half piece here, okay. So then what happens here? What happens here? The size is decreased, okay, the mass is decreased, and the volume also decreased. Okay, the size is decreased, mass is decreased, and volume also decreased. Right. So here these are called extensive properties. Okay, extensive. See your definition. It's a property of a substance that depends on the quantity or size of the matter present in the system. So example, mass, volume, internal energy, enthalpy, entropy, these all are comes under the extensive properties. So extensive means what? If the size, okay, of the system changes, then which properties changes on changing the size of the system, then those properties are called extensive properties. Here in the extensive properties, students, you can see so many things like internal energy, Gibbs energy, entropy, like this, so many things we see, and these all terminologies are very new to you because you are in 9th class, and these all one by one we discuss, okay, in the coming classes. Right. Now then come to the intensive property. What are intensive property? The properties which not depend on the size of the system, which not depend on the size of the system, okay, are called intensive properties. Okay. So here the property of the system that does not depend on the quantity or the size of the matter present in the system is called okay, are called intensive properties. Okay. What are example? example you can see like density. Okay. So, density formula is what? Mass by volume, you know that. Alright. For example, I have some matter. So, these are some solid substances there. Let's imagine this is a solid substance. Okay. And this is made up of some matter, whatever it may be. You can take some solid substance. This is, for example, I am taking. Okay, otherwise we can take to understand you. So, I am taking some metal block. This is a metal block, and metal block of I am taking gold. Okay, this is what a block of gold. Right. Now, I find the density. Okay, of this one. I find the density of this total block. Then, what is our density? So, D1 I will take here. Density is equal to total mass by total volume. Total mass by total volume. So, that I will get the density. Alright. Now you see what I do is, I cut a small piece of this one. Okay. I cut a small piece somewhere from here. Okay. I will cut a small piece from this block. Okay. Somewhere like this. Now, this looks like this, a small piece. Okay, I cut here. This is a small piece. I cut here. Alright. Now, if I want to find the density of this one, okay, now we are finding the density of this one, that is D2 is equal to mass by volume. So, see here, now I am taking a small piece. So, the mass will be decreases. Alright. Here I have taken the big piece, big solid block. So, the total mass is more. But I have taken a small piece of gold. So, here the mass is m, okay, and the volume is also small. Okay, volume is also small. So, I am taking volume. Now, I will get a D2. Now, you say, students, in both the cases, both the cases, does means D1 is equal to D2 or not? Density of this piece, that is equal to density of the second piece or not? Yes. Okay, because density does not, so here density here of any matter, if you take, the density remains the same. For example, if you take the gold density is same, even if you can take a small piece or a big piece. Okay, so the big block, then the density remains the same. So, meaning is what? Density is not depend on the size of the matter or size of the system. Here we are going to discuss, use a word called system, because system is what on which we are studying exclusively about one particular one, that is called system, right. So, here the density will not change whether it consists of more matter or it consists of less matter. Clear? So, density is an example for the intensive properties. Apart from this density, more or what are there? So, you can see the boiling point, freezing point, vapor pressure. These all okay, does not depend on the size of the system. So, they are independent to the size of the system. Even if you take the small quantity, even if you take the more quantity, these properties, okay, remains the same. Okay. So, in this also we can come across so many things like surface tension, viscosity, specific heat, refractive index, so many things, new words are there, and these all are examples for the intensive properties. And about all these things we will discuss slowly, step by step, okay, in the coming topics, right. Sure. Now, let us come to the state of the system. Sure. This is also a very important point, state of the system. Students, here state of the system is what? Here, for example, we are taking some gas, okay, in some cylinder, okay. So, let you imagine this is one cylinder, we are taking, okay, some gas, okay. So, this is a gas, right. Now, the gas will have some properties, okay, like volume, pressure, temperature. So, mainly we are going to discuss about these three topics, like pressure, volume, temperature, okay, mainly these things we are going to discuss here. Here, state of the system means what? Here, it explains about the, like what is its pressure, volume and temperature, means like, okay, for example, let I am taking this cylinder, in a certain amount of gas is there, and it exerts a pressure called P1, I will write P1, and it has a volume of V1 and the initial temperature is T1. Okay. Now what I do is, listen carefully here. Now what I do is, here if I change any one of this one, okay. For example, if I increase the pressure, means if I increase the pressure, then the remaining quantities whether changes or not? Yes, changes. Because when you increase the pressure, the volume will be decreases. Yes or no? The volume will be decreases. So here, if I am changing one quantity, okay, then what happens? That affect the other quantity also. That affect what? Other quantity also. If I am changing the temperature, then this also affect the total, okay, other quantities of the system. Is this clear to you? So the properties, if one quantity is changed, so that will affect the, means the other quantities also will changes. So such system is called okay. So condition of the system, that's called state, okay, of a system. So you can see, students, here it means the condition in which the state is present. Okay, under which condition the state is present is called the state of system. The system is said to be a certain state when its macroscopic properties have definite values, okay, like pressure, volume, temperature, etc. If any one of the system, if any one of the state function is changed, okay, then the state of the system is also changed, is said to be changed. So such okay, system is called the state of the system. Is this clear to you, students? Okay. So this is about the state of the system. Alright. So here one more important thing here. State of the system is independent to its path. Okay. Independent to its path means what? In which path it's reached to the other state is not important here. Okay. In the state of system. Okay. Now let's come to the next one, path function. Okay. Next one is what? The path function. Path function. Yeah, path function means what? The property of the substance that depends on the path. So here I said that, see students, here I'll be taking two examples. I'll take, for example, you see in your language, okay, generally for your understanding. For example, let's take, this is your house, your home, okay, and here it is your school. This is your school, okay. So here initially you are at the house and finally you are reaching to the school, okay. So in reaching from house to school, in reaching to the house to school, so here you may reach like this direction, okay. You may reach in this direction like this, and you can reach some other direction also like this, okay. So in this direction, okay. But the thing is that your parents check that whether you went to the school, you are going to school or not, okay. So generally they ask you whether you went to the school or not. They don't ask you in which path you went to the school. Yes or no? You have started from the school, right? And you are going to the, so you have started from the house and reached to the school, okay. Then your parent asked you, did you go to the school? Yes. They just ask you, did you go to the school today? Yes. So they ask that, did you go to the school? But do they ask like in which path you went to the school? That's not important, okay. So your initial position is house, final position is the school, right? So here also, for example, if one of the property changes, for example, if I am changing the temperature of this, so their temperature is what? T1. If I change the temperature to T2, for example, I change the temperature to T2, then automatically what happens? The volume also changes and the pressure also changes. The meaning is what? The state of the system is changed. The state of the system is changed. But here we discuss here only final and initial states here. We are going to discuss only the final and initial states, but we are not discussing how did it reach to the final state. Clear to you? So that is a state of system. But here you see path function. Path function is what? Here this plays an important, in which direction, in which path you went. Okay. So here, for example, you are starting from home. So in which path you went to the school? This is important here. In which path you went to the school? That is important. Okay. So path function means what? The property of the substance that it depends on the path. That it depends on the path. How that substance is derived. Okay. How that substance is derived. So it depends on the path. So such a function is called the path function. Is this clear to you? Path function. Okay. So that's about the path function. Okay. Now then come to the various types of processes. Students, here we are going to discuss this also very important. Various process of systems. Various process of systems. Okay. So here we come across, so if you have a material, you can open the page number 76. We have various process systems out there. In that, first one is called isothermal process. Isothermal process, right? And the second one is called adiabatic process. Adiabatic process. And third one is isobaric process. And fourth one is isochoric. Okay, isochoric process. And last one is cyclic process. Right. So students, here isothermal, already we discussed in the last class. Iso means what? Same. Iso means what? Same. So the system in which the temperature remains the same. The process in which the temperature of the system does not change, okay, throughout the study is called isothermal. Means what? The temperature remains same. Throughout the study, the temperature is not changing. So that is called isothermal process. And here the isothermal process, the important points what you need to remember is the temperature means change in the temperature is 0, delta T. Delta T means what? Change in the temperature or difference in the temperature is 0 because the temperature is not changing. So there is no change in the temperature. So hence delta changes, delta temperature T is 0. And heat is exchanged with the surroundings. Heat is exchanged with the surroundings, right? And system can be placed at a constant temperature, so temperature remains constant. That is about the isothermal process. Now then come to the adiabatic process. Adiabatic process means what? A process in which exchange of heat between the system and the surroundings does not take place. So here in the system, what I said, there is a change in the exchange of heat between the system and surroundings. But here in the adiabatic process, the exchange of heat, okay, exchange of heat does not takes place between the system and surroundings. Okay, the meaning is what? No exchange of heat takes place. No exchange of heat takes place. So the temperature of the system may vary. Now, isobaric. Iso again, let's see. Iso means what? The same. Baric means what? Pressure. Baric means what? Pressure. So a process in which the pressure of the system remains constant throughout the study. Okay, so pressure does not change. Delta P is equal to 0. There is no change in the pressure. So see, a process in which the pressure of the system remains constant throughout the system is called the isobaric process. Right? Next, isochoric. Isochoric means what? Volume. Iso means what? Same. Volume. Isochoric means same volume. So same, a process in which the system remains at which volume of the system remains same. So here pressure same, pressure same, here volume same, volume same. Throughout the experimental study, the volume of the system remains same. So that is called isochoric. and volume, when it is volume remains same, what is doing experiment is done in a closed vessel. Okay, the closed vessel, right? Then come to the cyclic process. Cyclic process means what? For example, you see we have taken one system, okay, and some changes are doing. Then what happens? The system is reaching. For example, you take A state. It's initially it is at A state, and then after some time, okay, that reaches to the state B. Then after some time, it reaches to the C. Then after some time, the state changes to D. Then again, it is reaching to the A. Okay. So here the changes are taking place in this process, and during these changes, it's attaining the different states from A to B, B to C, C to D, and finally again it reaching to the A, where it reaches to its initial state. Okay. So that is called the process in which initial state of the system is regained after the series of operations. Regained after the series of operations. So your initial stage of the system is what? A. On some operations, it's going to the state B, and then it's going to the state C. Again, it's going to the state D. Again, finally, again it's coming to its initial state. So this process is called a cyclic process. What it's called? A cyclic process. Okay. So students, here in this terminology is very important. So remember that isothermal. Iso means what? Same. Thermal means what? Temperature. If the temperature throughout our studies, the temperature of the system remains same, then that is called as a isothermal. And in the isothermal thermal process, delta T is equal to 0, and here heat can be exchanged with the surroundings. Adiabatic process means what? Here exchange of heat, okay, does not takes place. Okay. And then come to the isobaric. Iso means what? Same. Baric means what? Pressure. Throughout our experimental study, if the pressure of the system does not change, then that's called a isobaric system. Isochoric means what? Here throughout the study of the system, during experimental study of the system, the volume does not change, means what? It's done in the closed vessel. And last one, cyclic process. If a system is at initial stage like A, after several operations, okay, it's going again, it's reaching to again the stage A, then that's called as a cyclic system. Okay. So these are some terminologies, students, and here we are going to discuss in detail in the next coming topics. So all first terminologies are important. So this thermodynamics first synopsis which is there, read perfectly, and let's have some practice questions here. So here see students, here page number 77 if you have once open. Thermodynamics law speaks about, means thermodynamics okay, laws explains about rate of chemical changes, no. Feasibility and energy transformation of process, yes. So here energy transformation will be taking place here, right? So the answer is B. Next, the subject under thermodynamical study is called. So about what we are studying, at which okay, substance we are studying, that's called what? System, universe, surroundings, boundary. System. Okay, the option is 1. Which of the following are true about a system? 1. Will do not have definite amount of substance? No. Energy and matter may be exchanged with the surroundings? May. Universe plus surroundings? No. Universe minus surroundings? Yes. This is system plus surroundings is equal to universe. System plus surroundings is equal to universe. System plus surroundings is equal to universe. I want system. So I am taking this surroundings this side. Okay. So then it becomes what? System plus surroundings. This plus is when you are taking other side of the okay equation, then what it becomes? Minus. So that answer is universe minus surroundings. So option is 4, students. The system where the matter and energy are exchanged with surroundings, that's called what? Open system. I said no, when it is open for water you are boiling, so water get evaporated, so the mass of the water is decreasing, means what? Okay, matter is decreasing, exchanging, and heat is also exchanging. So the answer is open system, students. That is 1 is the right answer. Okay. Then come to the next one, 5th one. The system where only the energy but not matter is exchanged, then it's called very simple closed system. Okay, the answer is what? Closed system. The system, next 61, the system does not exchange either matter or energy with the surroundings is called isolated. What it's called? Isolated system. Right. Hot water in a thermos flask, no, is an example for which system? Thermos flask. So, generally, thermos flask, you know that when if you want to, if you are studying during the examination timings, okay. So, mom, what will do? She will take some milk and she'll boil and she'll mix the Horlicks and everything and she'll put the thermos flask. Okay, keep it aside with you whenever you want, you can drink. Why? Because it will be hot. Okay, so here what's happening? Heat is not transferring from the surrounding to your milk, or the hot milk's heat is not transferring to surroundings. So that's called isolated system. The answer is what? Isolated system. Which one of the following statement is a false? Work is a state function. Yes, work is a state function. So that is the answer. Next, ninth question. Which of the following is a path function? Work is there. See here, work is not a state function is given. So work is the example for the path function. Temperature and heat are extensive properties, intensive properties, intensive and expansive properties respectively. This is right. Temperature is an intensive property and heat is a extensive property. So the option is 3. Okay. Okay, students. So with this we stop today, and the remaining exercise part you do it. So first read the topic lesson, very important. So read it first and try to answer the next questions. Okay. And see here we are going in depth of the thermodynamics chapter, and here whenever you are going to discuss about those topics, all these words will come. So again, it is not possible to explain every time what is isothermal, what is adiabatic, or what is isobaric, this one. Okay. So that's what. So first build up your concepts. So first you try to understand this concept and read in the textbook, fix in your mind all these things. So when you are going to the next topics, okay, it will be easy for you to understand this thermodynamics chapter, because it's a new topic for you. Okay, you are in 9th class, so it's a very new topic for you. Okay, so with this we stop, and until, take care of yourself. Okay, thank you. Bye.